Efficiency of lamps. A normal filament light bulb operates by passing a current through a thin wire or filament to heat it to such a high temperature that it emits visible light. Unfortunately, it emits much more infrared radiation than visible light, meaning it's giving out more of its energy as heat than light. And in general, we use lights to see rather than because we're cold. Filament lamps therefore have a very low efficiency. Energy efficient light bulbs, which are normally compact fluorescent lamps or CFLs, pass an electric current through a gas. This excites the electrons in the atoms to higher energy levels, and when they drop back down to lower energy levels, they emit ultraviolet light. This we can't see, but it does cause the phosphor coating on the tube to emit visible light. CFLs can be up to 5 times more efficient than filament lamps. They do last longer than filament lamps, but cost more to buy in the first place, though the cost is falling rapidly. Let's look at an example of the cost of operating the two types of lamp. Calculate the cost of operating the two lamps below for 3 hours a day, which we can estimate as 1,000 hours a year, for 10 years. The lamps have a similar light output, and we're told electricity costs 7 pence per unit, a unit being a kilowatt hour. Here we have a table of data on the lamps. So the filament lamp will cost us 50 pence to buy. It will last for 1,000 hours and requires a power input of 60 watts. The compact fluorescent lamp costs £1 to buy, but will last 10,000 hours and only requires an input of 12 watts. I'll just add the equation to work out the cost of electricity is equal to the power in kilowatts multiplied by the time in hours multiplied by the cost of 1 unit. To work out the electricity for the filament lamp, the power in kilowatts, well, 60 watts, is 0.06 kilowatts, multiplied by the operating time of 10,000 hours, multiplied by the cost per unit of 7 pence, gives a total cost of the electricity of 4,200 pence, which is £42. Over this time we would need 10 lamps at a cost of 50 pence each, as each lamp will only last 1,000 hours or 1 year, giving a cost of lamps of £5, and therefore a total cost of £42 plus £5, which is £47. Now to do the same calculation for the CFL. The electricity, well, the power in kilowatts, 12 watts is 0.012 kilowatts, multiplied by the time of 10,000 hours, multiplied by 7 pence per unit, gives a total cost of electricity of 840 pence, or £8.40. One lamp should last the whole 10 years, and so it will cost us 100 pence, but just for the one lamp, which is £1, giving a total cost of the £8.40 plus the pound, which is £9.40. There are other factors to consider when looking at the total environmental cost of using CFLs. For example, CFLs require more energy and more raw materials to produce in the first place. They contain mercury, which can cause contamination of the environment on disposal. If the building is being heated, extra energy will be taken by the heating system if CFLs are being used, as we will lose the heating effect of the filament lamps. If the building is being cooled, further energy savings will be made, as the air conditioning system won't be working quite so hard to remove the heat given out by the filament lamps. The longer life of CFLs can lead to extra savings and convenience if the lamps are in hard to access places. Just to quickly look at another rapidly emerging light source, that of LEDs or light emitting diodes. These can be very efficient, but are currently quite expensive and so are mainly used in battery-powered applications, where a longer run or burn time is important. Technology in this field is, however, moving on very rapidly, so we may soon see LEDs in our homes.